All right, so today we're going to talk about glaciers and a little bit of the ice ages. Over the years, I've been adding a bit more ice ages into it. I wish there was more, but there isn't. I traditionally show a movie and a worksheet along with this one in order to talk more about the ice ages, and also because it deals with local New York history, but we're kind of out of time. Sometimes it even shows up as the last lap, but again, in a last-minute decision yesterday, I ran Hoover Dam, a flooding lab, a flooding video kind of thing. So, is what it is. I don't know what kind of image of a glacier you may have in your brain, if any. I'd be willing to bet it comes from one of the Ice Age movies. Which isn't horrible, but it's not accurate. But having an image of a glacier in my head for many years before Ice Age even came out, I'm going to tell you that it's probably the same image. But mine's ingrained from some misinformed diorama that I saw in a museum in the 70s and 80s, and it probably involves a giant hill of ice and some people and woolly mammoths wandering around in front of it and some scrubby, brushy area. And while that may be what the front of the glacier looks like, and we'll certainly talk about that at some point, what you've been staring at for the last couple minutes, let me put it into full screen here actually, is actually what a glacier looks like. You see that white river? That's a glacier from the top. So we've been talking about from the front. It is a river of ice. It flows. It doesn't flow anywhere near as fast as a river. It's a lot harder, creakier, and colder than a river. But for all intents and purposes, it looks like a river. Now, there's a couple things that come to mind when you talk about glaciers. Most of what we're talking about are what they call alpine glaciers. Up in the mountains, where the snow never melts, if hardly ever melts, and it's allowed to build up over years and years and years and years and years, thousands of years. And it just grows because of that. And then there's these ice sheets, okay, that are currently at the poles, that occasionally throughout history have grown and grown and grown and grown and grown and come as far down as New York State, Ohio, PA, Indiana, all the way across, go the other way, Massachusetts and whatnot. I don't know my southern hemisphere, but probably not quite as extreme. In general, the southern hemisphere is a little warmer. But so it probably wasn't quite as extreme down there. But that's the other image that comes to mind when you think about glaciers, hopefully. You probably also heard that the ice, we'll just call it the ice in quotes, is melting, is receding. That is true, and that's true regardless of which of those two you're talking about, the ice sheets. But even the more traditional, if you would, glaciers, they're receding, they're disappearing, okay? And I am by no means coming out on the end of climate denier or anything like that. Please don't think that I am. But you're going to hear me several times say that this is a natural process that we've come in and out of many, many times, and that is totally true. We come into and out of ice ages a lot over the last 4.5 billion years. The difference now is we're monkeying around with things, and we're seemingly accelerating it. Okay, that is the primary difference now. So it's a natural process that we are accelerating. All right. So, anywho, let's move on. There's another view. And it's just sort of snaking its way, meandering its way, to use a stream term there, through a valley, probably a valley previously carved by a similar glacier. You'll also note, if I can find my mousey, where you at, mousey? You'll also note some cracks in there. We'll talk about those cracks a little later. There's some more over, I guess I can't mouse sideways and upside down. There's some more over here. And you notice they're on the bends or the flow points. All right. Anywho. All right, so a few moments ago I mentioned that there are areas of the planet where there's always snow, at least for the time being. Closer you get to the equator, the higher up that elevation or altitude is. Elevation's the right word since we're dealing with the land. So, for example, you could go to Hawaii or Costa Rica or any other tropical place you want to think of. And if they have a high enough mountain there is quite probably snow all year round, even though the rest of the place is, okay, quite tropical. But you don't even have to go there. In the end of your geology bachelor's, that you go to something called field camp, and they send you typically out west, especially if you live in the east or the Midwest like I did, where there's a lot of soil and stuff and you can't see any of the rocks. They send you out west. So I got to go to Four Corners area. I went to Colorado, New Mexico, and Utah. And it's 4th of July. I remember it well because we were sitting at the top of the mesa watching fireworks from like the height that they were exploding, which was a really unique experience. And then the next day we went out into the field and went up a mountain to do something or another, and there was snow. So it had been, 80 the night before, and the next day we saw snow. So it's all about elevation. As you see, latitude will tell you what elevation you can get that snow at. You got your poles on either end here. Okay, so sea level is the lowest line, and then you go up. Sorry, it's in metric. Nothing I'm going to have you remember anyhow, but you get the idea there. Closer you are to the equator, the higher you have to go up in the mountains to find snow. Closer you are to the poles, the lower. And that's, again, any given time of the year. This is date irrelevant, season irrelevant. This is sideways, only because I didn't want to shrink it a whole lot. So there's going to be a similar diagram in your textbook, all right? And all this is really showing us is the stages that this snow goes through as it builds up, as it turns into ice. And there's an implied time scale as well. Again, just remember this takes thousands and thousands and thousands of years for it to build up. Again, I've said this many times, I didn't grow up here. I was astonished to find these giant slabs of ice on my roof the first year or so that I lived here. And I've lovingly / jokingly called them roof glaciers ever since. And everybody laughs at me, but they don't give this lecture 3 times a year for the last 25 years. It's the same stuff, okay? It just happens a little quicker on your roof because your attic heat and everything leaking out. Everything goes through this process, and you're left with, and luckily, believe it or not, looking at me, I once had semi-cat-like reflexes. I had no clue. I'm poking at this thing with a rake or a shovel, something, trying to get it off my roof. And I hear, and thank God I jumped back because it was probably 3 feet tall, 2 foot thick, and a good 3 feet wide. Several 100-pound hunk of ice came off my roof. It's a roof glacier. So this winter, we're headed in there now. When you see that stuff, and also at the end of your driveway, thanks to the lovely plows, that pile of snow that's sometimes there until May, you can't even get your dang shovel into, same stuff. Okay? Again, just augmenting it, human nature, But out in nature, this takes a long time. And think about the volume, too. All right, how much snow has to build up to make these massive, massive things. So that's why I can, tell you thousands of years, but also, anecdotally, we build these after a good storm in Utica. So, glacial ice. We got a vocabulary word embedded in here, and it's fern. I don't know why we picked this one term out of all the other things. You know what snowflakes are already. I guess we don't care so much about granular snow, and glacial ice is, I guess, fairly obvious. So the vocabulary word here is fern. And fern are basically these little snowy ice balls. That's what you may have gotten in trouble for hitting your little brother or sister with a snowball. You pack it really tight in your hand, and it's no longer that nice fluffy snow. It's practically a hunk of ice. That's that stuff. And little bits of that stuff, again, meld together over the years as it goes from snowflakes to these little pellets to the fern, which is big, hard, snowy ice pellets, to that glacial ice. So fern with an I, not the plant. All right, another word you've probably heard, not cared too much about, is permafrost. Remember, lots of vocabulary in this lecture. Permafrost is that referring to the soil, all right, or the ground, if you just want to use that word. The area of the ground that is, guess what, permanently frozen all year round. All year round. So up top there, as you may have guessed, we've got the continuous permafrost. In other words, the soil is just frozen all year round. This is an old slide. I'm hazarding the guess that maybe, if things are as extreme as the climate scientists are telling us, that line may have moved a little bit. Certainly the lower one, the discontinuous permafrost, has moved a little bit. Again, assuming, excuse me. Discontinuous permafrost means that it's not all year. So it's not actually permafrost. Alpine means in the mountains. So alpine permafrost is, again, where you've got soil in the mountains that is always frozen. And just to show you how things have changed, you got your Great Lakes there for reference. Just in case you aren't sure, you should be, but just in case you aren't sure, you live there. That's Lake Ontario. And you live right abouts there. So you see the dashed line there. I told you that the glaciers came down fairly far during the last ice age. So there's your southern limit of the permafrost during the last ice age, which, by the way, ended about 10 to 12,000 years ago. You'll see numbers anywhere from 10 to 20,000 years ago. It really depends how far south you lived as to how long ago you'll hear that the glaciers retreated from your area. All right. I grew up in Ohio, which is really only a hair souther, if you allow me to conjugate that way. Just a hair souther than here. And I've grown up hearing about 10 to 12,000 years ago the glaciers receded. But I do still see these, folks claiming, 15 to 20 that the last ice age ended. So, it is what it is. But, and again, in 4.5 billion years, does 1,000 years or so really matter? No. But with regard to human history, yeah, 1,000 years is a big chunk of change. We were here then. That's one thing that those dioramas really didn't have wrong. There were, I'm going to use the term cave people, pardon that word, wandering around killing woolly mammoths and mastodons and saber-toothed tigers and whatnot. All right, we were definitely here 10, 20,000 years ago. Homo sapien goes back to 2 million years. All right. But with regards to the last ice age, you know, we were definitely here doing our thing. Just had to move a little south to do it. All right, not a whole lot of stuff we need to pull off of this one. This is really just trying to go back to one of our opening statements about that this ice flows. Okay. Glaciers, there is some slide going on. Picture it like, you guys probably grew up playing with the slime. That made a resurgence. You know, you guys had that really fancy slime. God knows how many $10 containers, $15 containers I bought of it for my kids. We had, you know, the stuff that they used to drop on Nickelodeon, this green slime that came in a plastic trash can at the store. But if you imagine that on an incline, it sort of does a mixture of sliding down it and sort of turning over on itself, rolling down. All right, and glaciers do the same thing. There's obviously some slip on the bottom. And I don't want to say, that's that word basal slip towards the back right there. I don't want to say that we're not concerned about that, but it's kind of a, well, duh, it's ice, it's on a slope, it's going to slide down, we get it. They're much more interested in the way the insides and the surface, the top surface flow. And you see the word plastic flow in there, and there's a lot of sort of over churning, and believe it or not, there's people that study this stuff, bless their hearts. As you can imagine, hopefully, the top of this is a lot colder than it is deep inside the glacier. Remember, they give you that really weird advice if you're ever, God forbid, stranded out in the thing, you can actually make yourself a snow cave and you'll stay warmer than you would if you were at the surface. So there is some insulating properties here where the center of the glacier, if you would, is actually a little more malleable and warmer, for lack of a better word, than it is up at the surface. So this is why you see all these cracks and everything up there. It is a lot more solid ice up there. It doesn't really flow. And because everything underneath it is flowing, in order to compensate or accommodate it, the top has to crack. And I pointed those cracks out to you on one of the previous slides. Told you to remember those, and here they are again, and there's actually a vocabulary word for them. But you're going to see the vocabulary word again, but it never hurts to write it down now. Crevasses. Right? That's fancy French talk for crevices. So crevasses are these cracks that open up on the tops of the glaciers because, as it says here, the top of the glacier is much more brittle than the bottom of the glacier. So as the bottom of the glacier is doing that plastic flow thing, the top is more or less going along for the ride, and it has to crack here and there. And I pointed it out, but I don't know if it registered with you at the time. Those cracks were forming along the places where it needed to conform to the surface, where it was going around a bend. Okay? So where the bottom of the glacier may be able to kind of ooze its way around, the top is much more rigid, and in order to go around that bend, it actually cracks. So why do we even care about crevasses? Again, it sounds like a pretty normal thing, okay? The problem with crevasses is crevasses eat hikers. There are people out there, you may even know some, who think it's really cool to go out and hike on glaciers. And bless, you know, again, it's amazing. It's a huge opportunity. The problem is, again, as you may have seen in movies, you know, you set your tent out the night before, you wake up and there's 3 feet of fresh snow and you get to go hiking for 8 hours the next day. You can't see those crevasses at that point because there's a fresh layer of snow on them. So you're hiking along, and this is why they tie themselves to each other and not just slipping on the ice and going over the edge. But God forbid you fall into one of these things. It's basically an icy crevice, pardon the reuse of the word there, that you ain't climbing out of. Okay, you would likely freeze to death way longer than you got, you know, ground up and crushed as this thing flows. But you know, you aren't getting out of it. You know, unless you're like Tom Cruise or somebody like that. Brad Pitt maybe could get out of it. But you get the idea. So these fresh snows come, they cover up the surface, you can't tell what you're walking on. So that's why we actually care about crevasses. So a lot of words on here, but not a whole lot that we care about with regards to your test, okay? The crevasses is going to show up. Basal slip is underneath, that it just flows. Basal means bottom, right? You guys, when you were growing up, you likely had two thermometers. They like to abuse babies by using the basal thermometer. It's like when your cat or dog goes to the vets, they don't put it in their mouth, they put it in the other end. Then plastic flow, all right, brittle zone. Again, you're not likely to see those terms, but have an understanding. It's not a difficult concept. And it will help you bigger picture figure out what's going on. More of the same. I don't think we need to linger. Okay. Now, a bunch of vocabulary. And it would really behoove you to draw like a little slope and a little slug thing going down that slope that's going to be your glacier. I know you're not art majors. I don't care what it looks like. But you ought to draw it because we're going to label it. So I'll give you 30 seconds to draw a slope, slanty line, and then put a blob on top of it going down said slanty line. Okay, we're going to start at the top. The top is called the zone of accumulation. Guess what happens there? Somebody tell us.
Snow accumulates.
Snow accumulates, yes. Snow builds up. This is where we feed our glacier. It is uphill. It is presumably much colder up there, possibly all year round. We don't know. We're out of context here. But it is certainly the area where they want us to think that we are building up this glacier, where we're feeding the glacier, and basically everything flows out from here. We're going to skip snow line for a minute. And we're going to go down to the zone of ablation. Zone of ablation. Don't write the word ablation. Let's call it wastage, which is another word that is often used and is not a foreign word to you. Guess what happens in the zone of wastage? It wastes away, right. Okay, we could say it ablates if you guys want to. You want to learn another vocabulary word? No? At least one of you responded. Yeah, zone of wastage is quite acceptable. This is where you get seasonal melt. This is where you're going to see all that breaking and cracking and the stuff that they keep telling you on the news. Oh my God, these ice sheets are breaking off and falling into the ocean. That's down in the zone of ablation. Okay? In between those two, somewhere. Again, it depends where this glacier is. If it's an ice sheet, if it's an actual alpine glacier, somewhere in between those two is the line where the zone of accumulation ends and the zone of ablation begins. Again, we're going to use a slightly different term that's on here. I want you to use firn line. Remember firn from a couple minutes ago? That glacial ice stuff, that proto-glacial ice stuff? So firn line, that's that dashed line going across the top. So the zone of accumulation ends at the snow line, firn line, and then we turn into the zone of ablation where stuff is wasting away. You see your crevasses, like I said, you see some melt pools, all kind of neat stuff like that. And then we're going to put one more anatomical part to your glacier here that you just drew. Terminus. Terminus is the very end of the glacier. Feel free to draw a little melt pool there if you want to. Okay, you could have your little slope ending at a lake or an ocean, and your glacier's flowing down to that. So the terminus is the part where the glacier is actually just melting away. The terminus is the end of the zone of wastage, if you would. So you have four things on your diagram at this point. Zone of accumulation, firn line, zone of wastage, and terminus. I'll give you a second to make that so. All right. Now, related vocabulary. Related vocabulary. Again, we see our crevasses again on here, those cracks. You don't need to draw them in, but that's what we've been talking about. Again, they're down here. Things are moving faster. Cracking happens. See the word calving on there. On the top left side, you see icebergs and calving and sublimation. We want to know about calving. Calving is the process of a cow being born. And somewhere to these folks who started this study of glaciers, that's what it sounded like, looked like, who knows what to them. This is where little bits of the glacier are breaking off and floating away or just falling down. It doesn't always have to be water, but we sort of always draw them that way. I guess because things, gravity brings things to sea level. But so calving basically forms icebergs. Okay? That's where icebergs come from. Big hunks of ice that have broken off of another ice sheet. And yeah, iceberg is, I guess, a vocabulary word if you need it to be. So icebergs calve off of the terminus. We use all our vocabulary in one sentence. Who remembers what phase change sublimation is?
Solid to gas.
Yeah, solid to gas. Good job. All right. Not super important here, but they're just, remember how I told you that this does tie into the water cycle? So not only do you have melt, which is solid to liquid going on, okay, and quite obvious, but you've got solid to gas happening here. It's that special kind of evaporation, if you would. Evaporation technically is liquid to gas, but this is solid to gas. So lots of stuff going on down slope. Melting, it's a huge mess. It is a wasteland, and that's another reason why zone of wastage works so much for us here, because when you see this stuff, it kind of looks like a war broke out there, and it's just the refuse of it. It is a mess. All right, so again, zone of accumulation, fern line, zone of wastage, terminus, calving, icebergs. Don't worry about the tunnels and the streams and the pools and the flow trajectories. We don't care about that. You could, though, take 14 weeks on this topic alone, believe it or not. In which case you would study it in depth. Another view. Same stuff, probably much closer to what you drew. Hey, wait till you see what I drew in a moment. You'll laugh. Again, they're calling it the snow line. Sorry. There's mine. And nudge, nudge, wink, 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 probably what you're going to see on the test. Keep in mind that I had made this with 1999's version of Microsoft Paint, probably. So it is what it is. What would we call D? Zone of accumulation. Excellent. C?
Fern line.
Fern line. B? Yep. And A? Terminus. Beautiful. Let's not miss those 4 points on this next test. I just gave you the answers. Well, your classmates just gave you the answers. All right, more about crevasses. If you haven't written it down yet, now's the time. More S's than any one word needs. It's those flow lines around the corners, cracks in the ice. We worry about them because they eat hikers. And the other crazy thing is you see these rocks sticking out here and there. This could be 100 foot of ice right here. Not that your crevasses are going to be that deep, but I'm just saying that it's really hard to get scale.
There's a hiker in the foreground.
I see that. I suppose it's not a stovepipe sticking out, huh? I've never noticed that one. Thank you.
It's got little footprints.
And I see the footprints now, too. Exactly. As soon as you said that. So there's somewhat of a scale for you guys. But my point is, it's sort of like they always say, the tip of the iceberg. Okay, that's just probably the tip of a mountain there, mid-ground, if you would. I never saw that hiker there. That's funny. And I haven't used Plummer, McGeary, and Carlson, which is where this text is from, in a very long time. This was possibly one of my original lectures. Okay, everybody's friend. Agents of weathering, erosion, wind, water, ice, and gravity, right? They are making a return for the final as well. This, of course, deals with ice, right? So how does ice weather and erode? Well, glaciers themselves, all right, can do whatever the hell they want. There's such a massive amount, literally mass, okay? They are snowplows, I joke. But they can carve holes through mountains. They usually start where valleys already are, so they just, augment those valleys. But rock means nothing to them. So they're talking about maybe some frost wedging here. Yeah, okay. But we're talking more about the changes that a mile-high wall of ice that is hundreds, if not thousands of miles long and hundreds, if not thousands of miles wide, what that can plow through. I'm way more interested in that than frost wedging. Okay. But the gist of this is that glaciers pick up just about anything they flow over. I used that word blob earlier quite purposefully. Okay. I know you guys probably haven't watched the movie The Blob, but you may have seen it referenced in many different cultural things. And this thing flows over stuff, and it incorporates it into it. And that's why the areas in front where everything melts out are such a wasteland, because all that stuff then tumbles out. Again, if you are into that kind of thing, you live in an area where all that wash melted out, and you may have heard someone say, oh yeah, the glaciers brought that. Oh yeah, the glaciers brought that. These giant boulders bigger than your car, okay? Especially when they're granite. They came from Canada. We don't have granite here. They carried them down in the great glaciers, they melted out, and boom, they're here for eternity. Also, the sand in Rome, the sand in Albany, all right? Glaciers brought it, dropped it. So, weathering and erosion is really, a wide spectrum of things that can happen. I'm interested in the special things that glaciers can do, okay, due to their size and their mass. And before we leave this slide, there is one vocabulary word. It's pluck. All right? Glaciers pluck. That's the process of them flowing over something and sucking it into them. So glaciers pluck. P-L-U-C-K. You see plucked on there once or twice. All right? So that's how those pieces of stone get in there. There's a few other things we'll touch on. Plucking would be weathering, right? Because it's the breaking down of rock. And then the glacier moving, that's the erosion. And eventually that plucked boulder gets dropped, that would be deposition. Just to put it in context of stuff we've been talking about. Okay. A lot of vocabulary words coming at you. When you have a mountain, when you have a glacier, you're not just going to typically have one glacier coming down it. You're going to have, one off of each side, so to speak. And at least in your educational diagram, all right, for educational purposes, as they say, you got a bunch coming down from this here mountain. if you think about it with regard to snow or rain falling onto your roof when it's raining, everything that falls to the side of this peak is going to go down to this gutter. Everything that falls to the other side of the peak is going to go down to the other gutter. It's sort of the same idea. All right. So the opportunity exists for multiple glaciers to form. They're just doing it for a dramatic effect here. And you can see on the left they've got glaciers merging and forming a glacier going the other direction, and just lots of stuff going on here. So the next slide is going to remove all this ice, and we're going to look at what's left behind after it flowed like this. Again, for probably thousands of years. Okay, so we're going to start at what was the top of the mountain, and it's still the highest point around there, and they call that the horn. You've heard of a horn here or there. The Matterhorn is one that comes to mind, and I know I tag my YouTube videos as safe for kids, but I'm going to use a word here in a minute. The mater is mother, and so this is the mother's horn, and you can probably guess, I don't even have to say the word, I suppose, what those lonely shepherds were thinking of when they were looking at that giant pointy mountain, I guess. A lot of our science, and we said this way back at the beginning of the semester, comes from what I like to call early observationalists, okay? And those early observationalists weren't exactly science trained, but they had one thing that's necessary for science: a lot of free time, as they're out there tending their flocks or their herds or whatever, okay? So they got to sit and stare. We got some astronomy from them. We got a lot of stuff from them, but one in particular is glacial geology and glacial terms. So a lot of these words aren't very, highfalutin kind of words. And if they say that mountain looks like a boob, then, well, we got to believe that that's what they thought. So, anyhow, the Matterhorn, the horn, it's what's left of the very tip of that mountain. So the glaciers slid down it, ground it out, all right, and left a variety of topography, as we say. In between two of the glaciers, we have this long, narrow ridge. Let's go back just a slide for a second here. All right, we're looking at, really any one of those ridges that's showing up, but they named the one to the left of the horn there, and they call it an arête. All right. That is a long, narrow ridge, long, steep ridge, whatever you want to call it, between two glacial valleys. I'm told it means knife edge, something like that, or blade. Sounds like stop to me, but I think that's just a very similar word. So a arête is a long, narrow ridge in between two glacial valleys. Cirque. I've got a really great picture of a cirque, so we're going to leave that alone for the moment. U-shaped valley. The folks, again, in charge of this get really, really excited because you wouldn't know this because we didn't do streams this semester. Streams carve V-shaped valleys. Again, which you'd never know anyhow because of floodplains and vegetation and so on and so forth. It's really hard to see a bottom of just about any valley in its natural state. But glaciers, on the other hand, don't carve V's, they carve U's. And again, that's probably due much more to the shape of the object that's doing the carving, the agent in this case. So glaciers carve U-shaped valleys. They have rounded bottoms, not angular bottoms. And if you think about a stream as a knife cutting through the ground, all right, and then growing again, that would make a V for you. But again, we're not worried about that this semester because we didn't do streams this semester. Oh, okay, what else do we have on here? Ignoring Cirque for a moment. Hanging Valley, okay. It was a glacial valley that got cut off by another glacier coming the other direction. I've jumped to the right side of the slide now. hanging valleys basically make really pretty waterfalls. Okay. And it's just basically, you know, your U-shaped valley. It's coming down, coming down, coming down. And boom, all of a sudden it's just sliced off. Okay. And you've got a very dramatic drop. And that truncated spur, similarly, is basically an arête that was cut off by said glacier cutting through the other direction. So there's really lots of hanging valleys here, lots of truncated spurs. They just picked one, you know, to conveniently point at and say this is what it is. So I think we've got some actual pictures of a lot of these after we talk about cirque. But I waited for cirque because of this really helps my awkward definition. So a cirque is a steep-backed, bowl-shaped depression at the beginning of a glacier. Steep-backed, bowl-shaped depression at the beginning of a glacier. It's really almost like an amphitheater, if that helps. This is where the glacier started. That would be the horn of the glacier, if you would, right at that top of that wall there. Those would be the arêtes coming down the sides. This is where it all started. And remember, we told you that there was a lot of overturn going on in the ice deep down inside, and that's what's going on here. It's really just digging it out. Again, a connection you could make if you're familiar with it is like at the base of a waterfall. It's always, you know, a lot deeper than it is a little further down the stream because that water's coming down the waterfall and just digging the hell out of everything at the bottom there, just from the sheer force of the water. And the same thing's happening here. This is where the glacier is pushing against, it's digging against, everything's turning around as it flows down that hill. And it just gouges the heck out of these things. And it gets its really unique shape, okay, because of, you know, the form of the ice. There's a hanging valley. And again, you see how sheer that is. So this countryside was just riddled with glaciers at some point. You know, they're flowing every which way, coming down all these hills. And again, just think of, you know, we'll tap Hollywood this time. You know, all those movies you may have seen that took place in the Swiss Alps or whatever, and all those hills just all over the place. Well, now imagine, you know, ice running down all those different directions at different times, carving through whatever's in front of it. Yeah.
Do the glaciers moving through an area make the soil better at growing plants and stuff?
No, they take it with them. Soil comes afterwards. It scours everything. It makes the soil where it lands probably better. Soil develops. That's another chapter we didn't get to this semester. Soils have to grow over time. Those trees, that grass, that everything that soil's in is just plowed down to bedrock. And that all has grown. Soil grows. That all has grown after the glaciers have gone by. But there's no doubt that where they drop everything off, if you can deal with all the rubble. Again, in South Utica is a great example. It's not necessarily glacial. We've got stream deposits here, but glacial deposits are very similar. If you live around that Sequoia Creek area and you've ever dug in your backyard, you know you can't go 3 shovels full without hitting a freaking cobble, okay? And a lot of these farmers' fields, and you're driving up north and you just see these rocks all over the place, or sometimes in a pile, or they made walls out of them back in the day. All right, that was all the rocks they had pulled out of their fields. So it's great soil, but you got to get all the rubble out of it first. So yeah, all that is after, long after. Great question, though. There's 3 horns, I'd have to say, but a horn. The one on the right, obviously, is the largest. But they are quite pointy, And again, a lot of weathering and erosion has happened after the fact, but you could imagine the glaciers coming down. And actually, right here, you could really still see a good-sized valley and possibly a glacier in there. It looks pretty melted, but that's probably just a snowfield. But right there, and then it turns a little bit here. So that's an old glacial valley in between those horns there. Another hiker, this one I've seen over the years. When we're looking at an erect, this one is snow-covered, but I think you could follow the ridge line. I'll run my mouse just in case. They're talking right here. And again, if you've got really great balance and crampons on your shoes, crampons are those spiky things that they put on their boots, that might be the most sensible place to walk right then and there. I would be tumbling down that slope, I can tell you that. But yeah, they often will hike along the ridge lines.
Looks like a sand dune.
Yeah. Well, snow blows in much the same way. Snow drifts. We call them drifts instead of dunes, though. Now that you say it out loud, I think about it. Okay. Did you digest that vocabulary? Because there's more. All right, so those white things are glaciers. And now we're going to talk about, we've been talking about weathering, right? And we've been talking about erosion because I've hinted several times that these glaciers, once they pluck material, they move it. Well, when the glacier melts out, which I've taught you happens at the front of the glacier, that material comes back out. It gets deposited. Well, it can also happen at the sides of glaciers, okay, for a variety of reasons. Again, in this case, for educational purposes, we're going to show you that the sides of these glaciers are melting out. The giant word at the top there is a moraine, all right, and a moraine is a depositional feature, a glacial depositional feature. And it is a ridge of sediment, a long pile of sediment. So all we're really doing here is giving you 8 different ways that you can get those piles of sediment. Yippee skippy, right? If you learn what the first word means, it's pretty simple. And again, this is going to be a diagram. I give you a much simpler diagram. We don't try to squeeze all these into one, but so let's start at the top left here. Lateral. Lateral means along the side. So your lateral moraines, simply speaking, are moraines that accumulate along the sides of glaciers. So a lateral moraine is a moraine that accumulates along the sides of a glacier, left and right, if you will. A medial moraine is really just a lateral moraine that, unfortunately for it or whatever, happens to have another glacier on the other side. So it's now a median, like we have on the road. Media means is middle. So a medial moraine is going to be between 2 glaciers. But for all intents and purposes, you're absolutely right. It is just a lateral moraine that, due to proximity, we are renaming. This is what happens when you allow scientists to get doctorates in silly things. They make more vocabulary words. All right, now we're going to jump to the front of the glacier, where the majority of these terms are going to come from, and where, if you have any confusion, it'll be here. Okay. So the first word is end moraine, and guess what? The end moraine is the pile of sediment at the end of the glacier, the terminus, to remind you of a vocabulary word. So these are the ridges or hills of sediment that pile up at the end of a glacier. The problem is that we have different kinds of end moraines depending on what's going on. So, For example, if there, you see the three ridges in front of the glaciers there? So technically speaking, you've got three end moraines right now. They're going to go in and they're going to give each of those a different name. Let's pretend for just a moment that there's only one at the edge of the glaciers. You would just call that an end moraine, okay, if there's only one of them. Now, to go back sort of the conversation we were having about soils a couple minutes ago, if those glaciers were to go forward, would those two moraines in front of the last one, or behind the last one, I guess, would they be there? If that glacier grows tomorrow. It's going to plow over, right? Yeah, it's going to plow over those two. So again, you would just have that one out in front. It would be an end moraine. So these others behind it are what we call recessional moraines. They only form because the glacier is receding or shrinking. So now, if you have moraines behind the end moraine, we call those recessional moraines. You don't have to understand the logic here, you just have to remember to label the diagram. Because guess what? We're now going to call that end moraine the terminal moraine, because it's the last moraine. So they're all end moraines, but they're different flavors of end moraines. So once you get more than one, your furthest one out becomes the terminal. The one behind it becomes a recessional. You follow? It's all an order of operations kind of thing. Do we need to go through that one more time, or you guys got it? Because the last moraine isn't even a moraine, which is annoying. Kind of like that aquifer that wasn't an aquifer. Yep, no, not one of them. So ground moraine. Ground moraine is, well, all right, let's actually go back. The mound or the hill builds up because the glacier stays in that position for a long period of time. Long enough for that sediment to pile up, okay? If, however, it is steadily retreating, it's not going to form a hill. It just kind of leaves a scattered covering. That's what ground moraine is, or you may see it in your textbook even called sheet moraine. All right, it's just a scattering. Picture, and you've probably not done this yourself. Hell, I've owned a house for 20 years and I've not done it myself. But you've seen people pushing those little things through their yard, broadcasting seeds or fertilizer on their grass, okay? So imagine if they're doing what they're supposed to do and walking steadily, they're leaving a constant coating over their whole yard. But let's say their neighbor or their spouse yells out the door and they stop for a minute and happen to leave it on while they're talking about whatever. It's going to pile up right there, right? And then you're going to curse and kick it around a little bit and try to keep walking and finish your job. Well, it's the same thing that's going on here. If the glacier stops for a length of time, how long, who knows, doesn't matter. But enough time to build up a hill of this stuff, all right? That's an actual moraine. That's how we got all these. But if it recedes quickly and steadily, it doesn't build hills, it just leaves a covering. And that's what that word ground moraine, or as I said, sometimes they call it sheet moraine. Well, let's go to a slightly easier diagram. So we got two glaciers in here. We got Glacier A and Glacier B. Again, real high-tech imagery here. So those darker things are our moraines. Let's start sort of at the top-ish, if you would, but let's start with the left there, and you see that the right is also named Z. Of all those moraines we just talked about, and I know they're right on the tip of your tongue, what are the ones, what would we call Z? What are the ones along the side of a glacier?
Lateral.
Lateral, good job. So let's assume A was here first because it's bigger. Before B grew into place there, where we have that W pointing, that would have been a lateral moraine. However, another glacier came through, and now those lateral moraines are in the middle. What would we call those? So a moraine in between two glaciers. Medial moraine. Good. Let's go over to T on Glacier B there. There's only one of them, so we can quite happily call that a what kind of moraine? An end moraine. Excellent. Now in front of Glacier A, we've got a couple moraines happening. So we'll go to the last one out, the furthest one out, S there. S would be terminal. No, terminal. End would be T. There's only one. Again, technically these are all end moraines because at some point they were at the end of the glacier. But once you get more than one, that's when we have to jump into that subgenre of moraines there. So S is terminal moraine. U, I tried to indicate, was a smattering, a dusting of stuff, and we just got done talking about that one. Ground moraine, excellent. Z is currently at the end of the glacier, but more importantly, it is behind the terminal moraine. So we call that, starts with an R, recessional. 1, 2, 3, 4, 5, 6 more points on the next test. Label it. Those of you at home, if you didn't label it, replay it. All right, it's actually more points because I'm going to ask you to apply your knowledge on the test. God forbid we actually step up Bloom's taxonomy one step. 2 glaciers, Glacier A, Glacier B. I ask you, Glacier A, is it growing or receding? Is it growing forwards or is it melting backwards?
Receding.
It is melting. It's receding. Excellent. Why? Because we've had these recessional moraines in place. How about Glacier B? And keep in mind, can't tell is an option. Can't tell. We don't know. Tomorrow it could plow over that one, or tomorrow there can be another moraine growing. We won't know. We can't tell based on this picture because there's only one moraine. We know that at the moment, A is receding, or at least has been. Argumentatively, it could start to grow tomorrow too. Don't overthink it, okay? But based on the evidence at hand, A has been shrinking. B, you don't know what the heck it's doing. It's a horrible picture. Yet another hike. The only thing that makes sense in here is the blue thing in the middle. It says lake. I agree. You can't really see any of the moraines they're pointing at here. But I think we could all agree that that is a lake. All right. So this is going to be another high-tech thing as I switch from one slide to another. I want you to pay particular attention to the end of the glacier. This is a very nice lateral moraine, though, okay, right here, along the side of the glacier. For you folks at home, let me move the mouse. All right, nice lateral moraine there. But so I want you to pay attention to down here. All right, now, again, potentially because I didn't take the best notes when I borrowed these pictures at the time. Don't know how many years is going on here. I doubt it's a season. One of the other things to look at is this melt hole opens up. Again, and that just really helps this whole thing to fall apart.
Looks like a big thing opening its eye and mouth.
Yeah, it's waking up, huh? There's a little tusk down here, maybe. A little ice monster. But, whoops. So, when they talk about these glaciers receding, these ice sheets receding, this is what it's doing. Where's all that water going? Very little of what's going back in the atmosphere. It's melting out in front, okay? And again, this is why they're telling you that sea level is rising. When this much ice melts, it's got to go somewhere. It's It's going back into the oceans. Back into the oceans. This is a much better picture of moraines. Okay, you see the U-shaped valley in the background there. And then in front of that, you've got those lovely moraines. You wouldn't know it probably walking through it. You certainly wouldn't know it coming up on an approach from left or right. But up in the air like this, very obvious and very pretty. Okay. I always say I'm going to skip over this, and then I forget that it is, I think, pretty sure a question on the test. So we're just going to talk about it. Because I really don't want to give you, there's so much vocabulary in this PowerPoint, this chapter. To introduce another one that describes sediment. The big difference between till, the big thing about till is it's unsorted, okay? And if you learned anything in the weathering and erosion chapters, it's that Mother Nature pretty much sorts things, okay? Be it through wind, rain, wind or water. Even gravity can sort to some extent. Generally speaking, given the time, given the opportunity, Mother Nature will sort things. We do find these just dumps, okay, that the glaciers left behind of unsorted stuff, and that's till. But my argument has always been of why not bother learning this word is because guess what? As soon as those meltwaters start in front of the glacier, well, they're going to sort. All right, they're going to sort that giant dump right out. But again, arguably, not to argue both sides of the fence here, but arguably, we do find these deposits, or they wouldn't have made a vocabulary word for them. Okay. But at a 101 level that we're at right here, I think it's more important that you learn that Mother Nature sorts stuff because of flowing water, because of blowing wind. So the front of this glacier, while at moment one, unless something really unique happens to preserve all that crap right there in place at that moment, it's going to get sorted out. So, anyhow, as just a general vocabulary word, till, collective term for sediment transported and deposited by glaciers. Okay? Simply put. I'm just arguing that you'll hardly ever run into it. Speaking of which, glacial erratic. Remember I told you about those giant hunks of granite, bigger than your car? They're called erratics. They're found randomly, hence the name. And literally they just melt out of the glaciers. And these aren't going to get sorted by water or wind, okay? Because they're just monstrous. You drive by some new business park or something like that, or sometimes even people's yards, and there's this giant rock in their yard. You're like, oh my God, why would they put that there? Well, more than likely, when they were digging the foundation, they found it there, and it was all they could do to get the sucker up and out of the pit. And like, you want to leave that here, right? Oh, good, thank you. Because people do pay for rocks, and ones that big, because of what's involved, are very, very expensive. So people seldom purchase those giant boulders. Again, more than likely they were deposited there by the glaciers, and they either worked around it or, like I said, somehow managed to roll it up and out of the basement foundation area, and it stays there for eternity. Long after that building is gone, that's for sure. Okay, the outwash plain. I've mentioned this many, many times. The battle zone in front of the glacier. I think I may have called it the melt zone, or a couple different words. Hopefully I used outwash. Technically speaking, yet another vocabulary word. Hopefully this one is sort of self-evident, so you don't really have to spend a whole lot of brain power on it. But they've littered this with more vocabulary words, and I don't really want you to have to worry about most of these. You see what happens? You've got moraines going across there. That's already a word we know, so let's start there. All right. What they're telling us in this diagram is that those moraines can get reworked by the meltwaters, sometimes by the glaciers themselves. There are little rivers that flow underneath the glacier. Again, it's just meltwater. You've got the heat of the earth, the frictional heat. You've got a lot of stuff going on there. The bottom of the glacier is pretty slippy. We mentioned that to you. It's sliding down a hill. All right. So there's going to be water trickling out. Over time, that builds up, and you've got legit streams coming out of the bottom of the glacier. Those streams will rework the moraines. Those streams leave deposits themselves. That one there in the center, esker. All right? An esker that sort of looks like a snake-shaped ridge of sediment. That is something that the stream built as it ran underneath the glacier. The only one that's I want to focus on here, we got to mention drumlins too, I suppose. Are kettles. Kettle lakes is usually what we call them. If you spend any time at in the Cape Cod area, it's riddled with kettle lakes. They call them ponds, though. All right. Any of those inland ponds in the Cape area. What happens? Remember those giant hunks of ice? We call them icebergs. When they fall off, and there's not a whole lot of water there, they leave a giant impact in the ground, which eventually melts and leaves a lake, if you could believe it. These things are huge. Right. So imagine if you were standing over a sandbox and dropped an ice cube into it. It's going to leave a little dent, and that ice cube will slowly but surely melt away. Well, if that water stays there, it forms what we call the kettle lakes. And as I said, this is a great place to see these. If you've had the opportunity to get out towards Cape Cod area, is there. They're all over the place. I think a lot of the ponds up north here, too, are formed that way. Don't quote me on that one. But I think a lot of those tiny little ponds up through the Adirondacks are also kettle lakes. Not 100% though. A drumlin. A drumlin is named after a drumstick, as in the chicken wing kind. And what happens is as the glacier flows over a moraine, it shapes it. I'll show you a picture in a minute. And the cool thing about it is you can tell the direction of the flow because, like that drumstick, they're pointy on one end and rounded on the other. And when you have fields of these, which I've been trying for 20 years to see this, if you go from 81 out of Syracuse down towards Binghamton, it's littered with them. Okay? And I think they're just so big that we look at it and we say, oh, hills. Again, you need to be flying out of Syracuse to Binghamton and looking out your airplane window to see the cool shape, to see the scattered nature of them. But when you're on 81 looking out the car window, you just see these giant rolling hills off to either side. But those are drumlin fields. Those are drumlin fields. Let me show you pictures. All right, so here, a little more about it. Drumlins, as I said, are kind of an important word for us around here. So the glacier moves over a moraine, and you get an elongated hill. So the gentle downstream slope oriented in the flow direction, and the steep is the upstream slope. So they're going to point, the pointy part of the drumlin points in the direction of the flow. Give me a second, you'll see what I mean. So it sculpts them. It's sort of like a aerodynamic sort of thing, except it's a hydrodynamic, if you would. So it's running over one of those moraines that it left behind in a previous period. And the flowing water on either side of it, the flowing ice around it, just sculpts it. And you're left with, there we go. You guys spent some time looking at topo maps. You're left with these cool little mounds. And going back and having the benefit of an aerial view, the scientists can then reconstruct what direction the glaciers flowed. And again, yes, some people actually care about that. Notice the huge 25-foot contour interval here. You would have like 3 lines on your map if I let you use that one. Okay, the esker, it's a meandering ridge of sediments formed under glaciers from meltwater. I don't care about that one. I'm not going to put it on the test. I want to get through to a few more vocabulary words here real quick because we're running out of time.
Worm.
Yeah, basically. Esker, snake, just it's supposed to be like a snake. So there's that disaster zone in front of a glacier. Told you it's just a mess. The outwash is the area that washes out. Okay, you got a kettle lake in there. I want to talk briefly about glacial grooves. I grew up seeing these because there was a lot of them around Lake Erie. There's a lot around everywhere, but we've kind of destroyed most of them. A glacial groove is what happens when a glacier does a key job, basically. Remember we told you it plucks up stones all over the place? Well, some of them stay at the surface until they get absorbed further into the glacier, right? So it's actually powerful enough to leave these gouges down the sides or the bottoms of a valley. All right, can't really see them in here. You can see them here for sure. I've been here. This is up an island on Lake Erie, Kelly's Island, and when they were excavating out, doing their development of this island, somebody had the wherewithal to say, "Hold it! That looks like something funky and important, and/or important." And they got in touch with a civil engineer or maybe a geologist. These things are big enough you could ride a sled through them. They're like water slides, okay? There's not a whole lot of them left. It's maybe 50, 75 feet of them. But basically a boulder was sticking out of the bottom of a glacier going over the area and just gouged the Jesus out of these things. I've seen them as small as pencils, narrow as pencils, whatever you want to say. And these are the biggest I've ever seen. I'm sure there's bigger. But... so glacial grooves, very cool. Calving we talked about already. Again, that is chunks of ice dropping off. You can actually see, again, don't worry about this, but drop stone marks. So the ice floats, and since it's ice in water, it's going to melt. Even if it's really, really cold water, that ice will melt. So all those little bits and pieces of rocks and sediment that it picked up the whole time it was going down the hill start to melt out. And you get this little drip, 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 drip thing. They call those the drop stones, right? And that could get preserved in the sediment, and you find it many, many years later. Finally, my most favoriteest, coolest thing, only because, you know, how often do you get to start a word with fjord? But you gotta love fjords, all right? And if you don't believe in sea level change whatsoever, you know what? Fine. But this is evidence proof that sea level has changed. Okay, first of all, where do you get all the water for the ice? We got it out of the oceans. So once we had all this ice, your coastlines were a lot further out. Gravity brings everything to sea level. These things are flowing down these mountains, and they flow till they hit the water, and then they melt, right? That sort of summarizes what we've just said for the last hour. Well, when sea level is a lot further out, they go a lot further out before they melt. So once we leave a period of glaciation and sea level goes back up, those beautiful glacial valleys flood. That's what a fjord is. Okay, and they're really, really cool. Back in the days of Vikings and stuff, these were your strategic sort of points where you might sit at the top of and pummel your enemies down with, you know, from above as they tried to infiltrate your village and stuff like that. But nowadays, you know, Norwegian Cruise Lines goes in there and people just point and take pictures with their cell phones. And it's a lot more peaceful that way. Really pretty stuff. And some of the most amazing things we've got to see out there. It's just monstrous cliffs up either side of you. And again, it's only possible because, you know, sea level changed.
You got the extra if you want to get harassed by Vikings.
Yeah, that's the show, dinner dance show later. This is kind of important. We've got literally just a moment or two. It's hard to see. You've got a similar image in your book, I'm sure. These red lines down here say end moraines. That's showing you the extent of the glaciation for the last, the extent of the glaciers for the last glaciation. Okay. Great Salt Lake, I want to point out over here towards Utah-ish, was ancient Lake Bonneville. All right, it was a lake back then. We have sediments, that's why we know. It is a remnant of a lake from that period of time. But you see these moraine lines, that tells us the end of the glaciers. And also you see some sea level differences there as well. Here's another view from the last glaciation, in other words, the last ice age. As I said, about 10 to 12,000 years ago, depending on where you are. And your Great Lakes are definitely flooded. You also see this black line here. That is old shoreline. Okay, so where you go now to the beach, you probably would have had, you know, depending on where exactly you were, another 20, 50, I don't want to say 100 miles, but a lot. All right, that was all exposed because all of that water, there was a lot of ice. How do we know that? We could look at the deposits. Again, you've seen, if you watch the Nature Channel, Discovery Channel, whatever, these villages that are completely and utterly underwater now. They didn't build them underwater, folks. Okay, they built them when that was the coastline. So in order for them to be under 50 feet of water, 50 feet of water must have flooded them after. So 10 to 12,000 years ago sounds like a hell of a long time for humans. But trust me, we were here, we were doing things, we were building things. And the glaciers were melting while we were here doing that stuff, so we experienced this sea level rise back then. We called it perhaps the Great Flood, okay? Because we were losing all of these cities and villages to water level rise. You guys grew up near the Finger Lakes, whether or not you ever went there, that's another story. They're so long because they were streams, all right? The glaciers came through, they gouged them out, they clogged them up, and they filled out with water. They're now very long, deep lakes. They were rivers. Jumping ahead, if the ice continues to melt, all right, you see our current coastline, you see the Ice Age coastline from a moment ago, you're seeing a predicted no ice, I don't want to say no ice, but a lot less ice, coastline. Houston, Disney World, Manhattan, pretty much all of Massachusetts, New Hampshire, Connecticut.
Good news is Florida's gone.
To some. Good chunk of Texas, Georgia, okay, all underwater. So, again, this is just based on something as simple as elevation and the amount of ice they're aware of. All right, I'm going to ask you guys, I know you've got other classes to get to, spend a couple minutes and look at these last handful of slides. It's not complicated stuff, but I do want you to be familiar with it. Okay, it's on the website. The PowerPoints have been there the whole semester. The Pleistocene is how you pronounce that. That was the Ice Age, in quotes. Okay, our Ice Age. There were dozens before that. But when we say Ice Age, this is the one we're talking about. Started almost 2 million years ago. Went to about, I got 11.7 on here. I'm not sure where I pulled that number out of. But that chart's within the 10 to 12 I've been talking about the whole time. So, and it was pretty much as portrayed in the movies and in these wonderful 80s dioramas. Oh, we're done. So, we live in the Holocene right now. Okay? Post-glacial and modern humans. Again, in air quotes for those of you at home that can't see me doing modern. Well, the quotes are actually on there. We've changed since these guys. Oh, there's no people in that picture. we've changed since these times a little bit. All right. And truly modern human. Homo sapiens sapien. For those of you that pay attention to stuff, we've actually got a subspecies that came out right in the post-glacial as we were able to thrive and flourish again. And we changed because of that. So, cool stuff. And we're basically ending here where historical geology kicks in, which is Geology 102. I'd love to teach it. I need 7 of you to take it. All right? And we can start a petition and actually get it running again. We used to go to the Natural History Museum at the end of the semester up in Manhattan, have a heck of a time looking at fossils and all kind of cool stuff. One of these days, maybe we can do that again.